So welcome to today's webinar titled Achieving Functional Safety in Safety Critical Embedded Systems. My name is Ben Harampili. I'm a pre-sales consultant here at Inland Software, and I'm going to be hosting today's webinar for you. What's on the agenda for today? After a short introduction of our company, as always, I'm going to give you an introduction into Functional Safety 101, and then talk about quality assurance and safety critical embedded systems development, then talk about requirements and testing processes before the live demonstration. The live demonstration will then be followed by a Q&A session where I will answer all of your questions to the best of my knowledge. And the webinar will be recorded as always, so you can view the recording on this link, but it will also be sent to you via email after the webinar. You can also check out our upcoming webinars on our website and register to anything that you find interesting. The next one is going to be on August 10th using Kanban and Scrum in practice. And you can also check out our previous recordings. Last week we had a pretty interesting one on the Scaled Agile Framework 4.0. So feel free to check out that recording as well. Few words about us. We were founded in 1998 and our headquarters is in Stuttgart, Germany. But we also have an office in the Silicon Valley, California, and resellers in UK, China, Korea, Taiwan, France, and Italy. And we're the sole developers and vendors of CodeBeamer ALM. Our rollout partners are Lufthansa Industry Solutions, but Lufthansa Systems is actually also our client, where we have over 5,000 users. So you can really see how scalable our product is. From small teams all the way to thousands of users can make good use of it. We focus on the medical, the automotive, and the aviation and defense, so the highly regulated industries. But we have clients in several other industries, such as the high-tech and embedded, and finance, and things like that. So, first and foremost, let me just clarify a few definitions before I jump into anything else. What is safety? Safety is the freedom from unacceptable risk of physical injury or of damage to the health of people, either directly or indirectly as a result of damage to property or to the environment. And then what is functional safety? Functional safety is the part of the overall safety that depends on a system or equipment operating correctly in response to its inputs. It is the detection of a potentially dangerous condition resulting in the activation of a protective or corrective device or mechanism to prevent hazardous events arising or providing mitigation to reduce the consequences of the hazardous event. Now, in the context of functional safety, the term risk is used to indicate a combination of harm's characteristics, the likelihood of its occurrence, and its severity, and the difficulties of controlling that risk itself. So the main aim of functional safety is to bring risk down to a tolerable level and to reduce its negative impact. But you have to keep in mind that there's never such a thing as zero risk. So functional safety measures risks by how likely it is that a given event will occur, and then how severe it will be. So in other words, how much harm it could cause. Now, the main objective of functional safety is to reduce or mitigate as many risks as possible and to ensure that your product has no potential to harm your users. Functional safety relies on passive measures and active systems. So safety achieved by measures that rely on passive systems alone is not functional safety. However, product safety is a result of passive measures, first, meaning the use of mature processes and adequate quality assurance throughout the process of development, and then active measures, meaning functional safety systems or devices that perform actions with the objective to keep the users safe. So in your car, for example, functional safety ensures that airbags instantly deploy during impact to protect you and your loved ones, but not when you're driving. And an example of safety achieved by measures that rely on passive systems alone, on the other hand, would be the bumpers on the front of your car, for example, that are built to withstand impact during crashes. So they can protect against the same types of hazards as functional safety, but are passive in nature. That's the difference. In terms of software development, there are certain well-established quality assurance methods that help developers achieve functional safety. First of all, bad requirements management is actually the single biggest reason for project failure. So that means that the efficiency and accuracy of this process, requirements engineering, is vital to project success. Good requirements need to be complete, testable, consistent, design-free, and unambiguous. And requirements presume that the design of the application is done beforehand and that development is the implementation of that design. Requirements therefore focus on how to implement a functionality, performance, and user experience, and are differentiated through functional and non-functional requirements. Your feature should then be developed based on only these requirements. You also have to make sure that all requirements are covered with features and adequately tested, and that no feature is developed without its defined requirement. Developers are using usually requirements-based testing and test coverage analysis to ensure all this, and while highly efficient, these techniques are really difficult to implement in practice. But specific software tools and platforms such as our CodeBeamer ALM tool and other application lifecycle systems, application lifecycle management tools, are used to track everything from requirements through coding, risks, and test cases, all the way to release and maintenance. And this ability to establish links between all of your work items, which is otherwise known as traceability, is a fundamental requirement of practically all the relevant regulations. Risks need to be managed throughout the entire life cycle of your development. So requirements for certain features can come with their own risks, which need to be analyzed, and proper mitigation actions need to be taken and planned. But the difficulty here is if you create a mitigation requirement to mitigate your original risk, then those could introduce further risks. So risk management has to be a multi-tier activity, which in turn further increases the complexity of your development. It's needless to say that software platform with robust risk management capabilities are needed to handle such levels of complexity. So in addition to requirements management, traceability, risk management, and quality assurance activities, the strict regulations and standards that apply to the development of safety critical devices require you to implement adequate process control. What does this mean? It's not enough that for you to define your mature processes, you have to enforce them, and you have used through these compliant workflows throughout the entire life cycle without any deviations. And when it comes to regulatory inspections and compliance checks, you also need to be able to prove that mature processes have been enforced throughout the life cycle. The general standard, the IEC 61508 and its derivatives, ISO 26262 for the automotive industry, and the IEC 62304 for medical device development, as well as a set of other standards, all contain requirements regarding the use of processes. These processes help ensure the safety and reliability of mission-critical end products. Complying with these guidelines and regulations takes discipline and advanced support tools, and one such tool is integrated application lifecycle management. These ALM platforms help you manage the entire development lifecycle, from idea all the way to the maintenance of the released software product itself. Advanced solutions such as CodeBeamer ALM also let you connect hardware, software, and service development, and it helps you orchestrate the multiple parallel development processes and life cycles of such complex products, all the while ensuring process control, traceability, and record keeping and documentation. Okay, so before the live demo, I'd like to say a few words about the standards, a few more words about our standards and our templates, more primarily our ASPICE template, since we recently finalized the template for it. ASPICE actually isn't about compliance itself. It is actually more of a guideline. And what are its main goals? First of all, reduce time to market, reduced costs. I don't know if you read this, but just last month, Toyota had to recall almost 3.5 million vehicles due to defective airbags and faulty emission controls, I think. So, yeah, fun fact. And punctual development. And what's really important here is reducing liability through capturing all customer requirements and capturing them correctly. So that's the most important here. And of course, improving customer satisfaction throughout the entire life cycle of the product. But there are a few things that are not allowed in ASPICE, namely leaving away processes entirely, leaving away work products, or leaving away characteristics of work products. So that's just to give you an overview, a quick introduction to ASPICE, which is actually a combination of these guidelines that help you achieve functional safety while improving your efficiency, reducing costs, and most importantly, like I said, reducing liability. On this slide here, you can see some of the industries that we focus on and the regulatory standards that apply to those industries: medical device development, automotive, and aviation, aerospace, and defense industries. We actually offer pre-configured templates for all three, so the medical, pharma, automotive, and avionics industries, as well as the brand new automotive SPICE template, all of which help you achieve functional safety and facilitate compliance. Now, it's important here to understand that using any tool will not make your products compliant automatically. So CodeBeamer also just helps you implement mature processes in order to help you develop high quality products faster. So in effect, process control, traceability, documentation, and reporting features help you implement a practice we call continuous compliance. Continuous compliance means that instead of trying to correct processes, establish traceability, and assemble compliance reports for audits at the end of the development lifecycle, you will already be using mature processes on the fly, so to speak, during the process of development. And with all processes designed to be compliant and enforced throughout the lifecycle, successfully preparing for audits will be much easier. Now, before I jump into the live demo, let me ask you a few questions, please. If you could answer the question on your screen, that would be much appreciated. If you could help us out by voting, please, that would be great. Okay, one more question. What software development methodology are you currently using? Just as an FYI for us. Scrum, okay. Make sure you join our webinar next week, or sorry, 2 weeks from now. Okay, great. Let me jump into CodeBeamer itself then. So I'm in CodeBeamer now. I have my projects overview here. And I'm going to jump into our medical template right away. Show you what that looks like a little bit. Each project has its own wiki page. It's kind of a home page for each project where everybody can stay up to date on the processes and things like that. It's kind of like a knowledge base for each project separately. You can define processes, add links to your documents. We have our software risk management process defined here, for example. How to use the medical template, things like that. Now what I want to start out with is I'm going to jump into my trackers here. You can see kind of the architecture of how our trackers are built. Each tracker has a separate workflow in the background, and yeah, they're kind of folders just to manage all of your work items. So I'm going to go into my customer requirements first. This is what we call the document view. And here you can edit your requirements in several different ways. But what I really want to show you is the traceability browser that we have, which you can use to show the relationship between all of your work items and provide gapless end-to-end traceability. I can start adding trackers, and those will be added by columns next to each. And already I can see the relationship from my customer requirements to my system requirements. And I can also load and manage presets. So the preset that I'm going to be loading here is going to be showing me or showing you customer requirements, all the related system requirements, the related software requirements, change requests, bugs, and then all change set trackers. If I load this, I'm going to zoom out a little bit here. Hopefully you can still see it well. I can see the columns of the trackers and all the relationships between each item. Custom requirements, system requirements, software requirements, change requests, bugs, and then the change sets. And if I scroll down, I have more relevant information here. It's more populated. I have a custom requirement, for example, touchscreen UI. I have these two system requirements that have been derived from that customer requirement. I have these software requirements that have been derived from these system requirements, and so on. Change requests, bugs, and then the change sets. And if I go into my bugs tracker, for example, and go into the source code commits, I can actually see the commit in the source code itself, and I can comment on each line of code separately. Okay. Also, you can see these little S icons here. That means that there's a suspected link has been triggered, which if I enter this work item, which is a software requirement, for example, and I open this tree of relationships, it shows me all of my suspected links. So as I can see, I have a test case verifying this software requirement, which has either changed or the software requirement has changed, which means that I have to review this link. And if I've reviewed it, I can click on the suspected link and then it will disappear. Same goes for if you reuse a test case or a requirement through our requirements and test case library, and then either of the two change, then either the original or the new one, then that will also trigger a suspected link, and you can actually click on the suspected link and then apply or reject all of the changes one by one or all of them at once. Okay, also in the history, I can see who did what and when. Everything is documented and traced, so I can check the history of each work item separately. I can also create baselines and for entire projects or for separate trackers, and then I can compare the two baselines. So right now I'm going to compare the head revision of this project, which is the current version, to a baseline my colleague created on May 9th. If I click on compare selected baselines, I can compare the two. I can see the statistical overview here. I can see my trackers and work items, wiki pages, documents, so on and so forth. And if I click on the show diff, I can see everything really detailed. I can see everything that's happened. So again, the history of all the items compared to the previous version, everything that has changed. Okay, so another thing I wanted to show you is our dedicated test coverage browser. So let's say I want to see the coverage of my system requirements or whichever requirements I have test cases related to. I can click on our dedicated test coverage browser. And if I expand this entire node, I can see all of my system requirements, all of the verifying test cases, and all the test runs and their results. So this is a run of the functional electrostimulation test. I can see that it has passed, and so I can see that this requirement is only partly covered, or incomplete, sorry, because not all the tests have been run yet. And then I can see all of the ones that are not covered with test cases that I still need to verify. I can open up the test coverage statistics so I can get an overview of my requirements and their coverage, and I can filter these results as well. For example, if I just want to see all the requirements that are not covered with test cases. If I remove this filter and I expand this node again, I can easily export this to Office. I can do a simple Excel export. And then after opening this up, I can see the coverage, and I have it in an Excel sheet with live links to each items here. As you can see. And the same code goes for the traceability browser. Let me jump back real quick and just show you how easy it is for auditing purposes, primarily, to just create an Excel export of your traceability and of your test coverage browser. Okay, another thing I talked about that's really important is risks. So let me show you, we have requirements-based risk management. So you can derive risks from requirements, and we also have a risk matrix diagram. So I have 3 risk matrix diagrams here: the initial risk, the risk matrix after mitigation, and the combined risk matrix diagram. And they show the number of risks and the number of related requirements or user stories in each cell regarding severity and their likelihood values. And if I click on one of these numbers, I can see all the risks and the related requirements and user stories. Okay, that's just a quick outlook into our risk management. And I'm going to jump into our newly improved advanced medical template and show you what workflows we have set up there. For our system requirements, it's almost the same as the other one. We added a few items that have been missing, few trackers like software of unknown pedigree, software systems, and a few other trackers. But we have we have an approval process workflow set up for system requirements, and another workflow that I'm going to show you for verification purposes mostly and things like that. So I'm in my system requirements for my advanced template, and I'm going to go into the customization of this tracker just to show you what this looks like. And in the state transitions, I can set up the statuses, their state transitions for this requirement tracker, and then I can see the state transition diagram as well. And if I expand the distance, I can see the chained workflow that's working in the background. So it's a bit complicated, but it's not that not that complex actually. So the system requirement, if one system requirement is set into the waiting for approval status, then that will trigger a sub-process or an approval task for all the owners. And the owners of the system requirement have to be quality engineers and requirement engineers. And both of them have to approve. But you can configure this to your own processes. This is just an example. But both of those approvers have to approve that task, or the requirement itself actually, through the task. And then that will set the status of the system requirement automatically to accept it. So let me show you what that looks like in practice. Let's see. Okay, so I have a system requirement here that's in the new status. And I'm going to set it to approve directly. And as you can see here, if I want to set it to approve, The owner field is marked with a red asterisk, so it's a required field, and I have to set a quality engineer, me for example, and then another demo user who is a requirements engineer, and then I have to specify these owners. And as you can see, the status has been set to waiting for approval. And if I double click on this requirement and open the detailed view, here down at the references, I can see this has created two subtasks, approval tasks. So both the quality engineer and the requirements engineer have to approve this one. So since I'm logged in as myself, I can approve this pretty easily. I just click on the task, click on verify, and then I have to add my e-signature, which complies with the Code of Federal Regulations, Title 21, Part 11 of the FDA. So I have to specify that I am signing this, and I have to add my password, and it is validated. So obviously, if I enter the wrong password, then it will not let me verify. Okay, and now I can jump back through the subject field to my original requirement, and I see my task, approval task is gone, but Erica, the demo user, still has to approve. So I'm just gonna go into my other instance, and here I am logged in with my my demo user, so I can easily approve it through a different instance. And I'm just gonna do the same thing just with the other user, so both engineers approve this requirement. Save, it's verified, and if I refresh the page, I can see this requirement has been accepted. So that's the approval workflow. And then we have another one set up where we're running out of time, so I'm just going to explain how that works. For the software requirements, I'm going to show you how it's set up and what you actually see on this diagram here. So how we have it defined is if you have a software requirement with a high value a safety, whose safety is high value, then that can only be accepted. So if the value of the software requirement is high, the safety value is high. Okay, finally I got it. And it is set into the draft. It can only be set into the draft status. As you can see, it cannot be set anywhere else from new. Then that will automatically create a test that has to be verified, that verifies this requirement, so it has to be tested. And it also automatically creates a risk that has to be mitigated. And so you cannot accept that requirement until it has been verified, tested, and the risk has been mitigated. Okay, so that's how you can really enforce your processes that you have set up. Again, it's highly configurable, so you can configure it to your own needs. Last thing I want to add is you can define separate roles for each project, and each user can have different roles, and the roles can have different permission sets. And you can also define for each tracker, even on the field level, you can define different permissions. So if I go into the customization of any of my trackers, I can see I have my permissions, so for the entire tracker, and all the roles, who can do what based on the role. And even for fields, I can have different permission sets per status for each separate field. Okay, so that's it. That's all I had planned for today. Hopefully it will help you in your functional safety needs. Thank you for your attention. Does anybody have any questions? No questions. Okay, well, before everybody exits, can I please ask you a last question? How did you feel about today's webinar? Everybody's leaving. All right, thank you. Okay, and just as a goodbye, make sure to join us 2 weeks from now using Kanban and Scrum in practice, August 10th. Thank you very much for your attention, and everybody have a nice day. Bye bye.